Here's the last type of real-world problem. Even though there's a lot of problems you can apply geometry to, these are just a few. So this one is about fencing. You have 67 feet of fencing and a 3-foot gate to enclose a space for your dog. What dimensions will create the maximum amount of area? So the maximum amount of area, if we compare a rectangle to a square with the same perimeter. So let's say the sides of our square are all 10, and let's say our rectangle is 15 by 5. So they have the same perimeter of 40, because 10 plus 10 plus 10 plus 10 is 40, that's our perimeter. And our rectangle, 5 plus 15 is 20, plus 5 more is 25, plus 15 more is 40. So that would use the same amount of material for fencing. Let's calculate the areas. For the rectangle, we have 15 times 5. So that will give us 75 square feet. So do you think the square will have more area or less? Let's test it out by finding the area. Area of a square is base times height, just like rectangle, it's base times height, or length times width. Both the same formula, but just different names. You'll hear both used. So the base of the rectangle is 10 times the height is 10, and we get 100. So the rectangle was 75 square feet, the square was 100 square feet, which means the square enclosed more area. So maybe a different rectangle has more area. We'd have to try them all, but it was discovered that in every case, a square is always the best shape to maximize area when you're doing a square versus a rectangle. So we always want to try and go for a square shape with our areas. So our square has 4 sides. We have 67 feet of fencing plus the 3-foot gate. So adding that together gives us a total amount of 70 feet all around the outside. That's the perimeter of the square. So to calculate the exact amount of the sides, we would just divide by 4. We want 4 equal sides. If we divide by 4, we get that each side is supposed to be 17.5 feet. So if you don't mind cutting the fence into that amount or just bending it, then each side should be 17.5 feet. Now there was the 3-foot gate. So on the last side, you have to keep in mind that wherever you want to put the gate, then the fencing around it will be 3 less than that. So the gate is 3. The fencing around the gate would be the 17.5 minus 3. So on that particular side, the fencing is 14.5 feet of the fencing. But for all intents and purposes, now we know that the dimensions are 17.5 by 17.5. And we could put the units as well, 17.5 feet by 17.5 feet. Now what if you were using a material where you couldn't cut it into pieces for whatever reason? Well, if that was the case, we would always have to round down. Let's say we had 1-foot boards and we couldn't do half of a board. We didn't have a way to cut it in half. In that case, we would just round down and say, well, that's going to be a 17-foot by 17-foot fence instead. We don't have the material to cut the boards in half, so we just have to leave those out. So that's how we maximize area for our fencing problems.